Okay, this will be video, I guess the official start of the fluid mechanics video series. This is Fluid Statics-1, abbreviated FS, and I'll be talking about pressure and work in this video. So, what exactly is pressure? Pressure is a pretty intuitive concept. You know, you push down on something, and it exerts a force when you do that. And why are knives sharp? Well, because there's a lot of force in a very tiny amount of area, which is the tip of the blade. That's why when that's just kind of makes intuitive sense. Like pressure is force over area. So if you have a knife, the tip of it is an incredibly small area and an incredible amount of force. It's essentially why it's so sharp, as opposed to a blunt object, such as a blunt knife. That does not have that's dull because there's a wider area for the same amount of force. Therefore, the pressure is not as great. But that's just intuitive. That's an intuitive notion. Now, I mean, there's also let me just rotate this a little bit. Okay, so in fluid statics, pressure is a very important concept because pressure of the fluid determines a lot of properties, especially in gases. Pressure dictates a lot of things in gases, but we'll talk about that later. And there's atmospheric pressure, which essentially the weight of all the little air molecules around pushing down on just a fluid column. If you fill up a glass of water, there's atmospheric pressure on that, even though it's not really moving. But that's just you just have a little piss. I mean, it kind of makes a lot of sense. Also, now that we talk about pressure, it's also necessary to talk about work. Now, work is a pretty simple concept. Work is essentially in a mathematical form. It's work equals force times distance. The amount of force you have, times the amount of distance you travel. Force times distance. And then we have power, which is work times. I need to probably change the P and the P because it might be a little not clear which one I'm talking about. But essentially here, power equals work, the work done over the time. Oops, work divided by time. I'm pretty sure it's work over. I'll look that up. I'm pretty sure it's work over time. How much power it is. You're right. It's a little mistake there. Anyways, but also work input equals work output. Such as I drew in this little example right here. We put in a force, and out the other side comes equal amount of force. It makes a lot of sense. It's kind of like if you have a instrument such as this, and you push down on it with I don't know, like a cork or something. You push down this end, the same amount of force will be exerted on the other end. Work input equals work output. And then also, the average work is work final minus work initial. Just a simple, basis, simple equation derivation in physics. I think it's just kind of intuitive. And so, yeah, essentially pressure is force over area. And atmospheric pressure is basically the pressure of the atmosphere, all the air molecules weighing down on just a column of anything, really. There's atmospheric pressure everywhere, but in this particular example, it's on a fluid. And so, and then of course here it's the exact same thing. There is atmospheric pressure going on to here, but in some cases in fluid static problems, atmospheric pressure can be negligible or just not really talked about, but it's always there. It's just sometimes a convention in physics to leave out certain forces for simplicity's sake, really. And so yeah, to really wrap up this video, what you need to take away from it, there's pressure, force over area, and work, which is force times distance, and work input equals work output. And just think of that, just kind of, fill up a glass of water and, push down on it. I mean, the water will go up. Work input equals work output. That's just another law of physics, conservation of energy and all that stuff. All right, so that's all for this video. Hope you guys enjoyed. The next video, we'll talk about density and more. We'll do a few examples of this stuff, actually. And, so that's all for this video. Hope you guys enjoyed. See you guys in the next one.